So, you know what really sucks is cell phone providers. They're bad at their job. And the biggest thing that they're bad at is understanding that voice calls and text messages are the same as data. So anyway, recently I stopped having a cell phone plan and started having a tablet plan. So this is my tablet. You like my tablet? It has this nice speaker microphone combination here. Yeah, it's good. Good sized tablet. When I got the SIM card, the guy said, "So you're gonna put this in a tablet or something?" And I said, "Yeah, or something." So that's pretty great. But obviously, I still need to be able to talk to people who have not yet become so enlightened. And so I need a way to use my data to send text messages, which it turns out there's like a billion ways to do. And I'm not using this yet. I'm using a different thing. But this is awesome. I wrote this. Yay. Okay. So what I want to do is just, well, actually I've got like a whole big, huge thing I'm doing. But like this is a piece of it. And a useful on its own piece that just bridges between your standard Jabber XMPP instant messaging protocol and SMS. It's just a normal gateway. You add it to your roster, and then you can just type in any of your chat clients and send SMS messages, which is great. That's actually what I already do, because as we will see, the provider that I'm using for this already supports XMPP, which is a bit of a weird choice, but they support it kind of poorly. So basically what this does is paper over all their inconsistencies. They don't provide a gateway. They make you log into their server to like their unfederated, well, actually it is federated. It's super weird. I don't think the people who set up the XMPP server at this company really knew what they were doing, but if you've interacted with this company for any period of time, you start to become convinced that they don't know what they're doing in any area of their business, so that's kind of okay. But the text messages usually do get delivered, which is all I care about, and they don't charge me anything for them, which is even better. That's really the reason I keep putting up with this company. A friend of mine is writing a similar gateway for another company, and we're going to eventually write gateways for basically every company that lets you send SMS, so that you can agnostically send SMS messages using the same protocol, the same syntax, in a uniform way, no matter what backend provider you prefer. That's part of the goal of this big project we're working on. Right now we've got this that I wrote for provider Vitality, and he's written one for Bandwidth AP. Bandwidth AP, you have to get on the phone with in order to get an account, but mostly they will give you one. Vitality, you just sign up on the web, but Vitality charges you nothing per message, and it's kind of shitty. And Bandwidth AP charges you ½ cent per message, and will let you do all kinds of fancy things like send long messages and Unicode messages. And Vitality is super shitty. If you try and put a plus in your text message, it just replaces it with a space. I don't know why. That's not my fault. That's not my code. It does that out of the box. They're so good. Anyway.
You didn't pay them enough to transmit your plus zone.
That's right.
That costs extra.
It does. It costs extra. I don't know. Yeah, my friend is like very confused as to why I'm still putting up with them at all, and the answer is because it's free. Yep. And I've cut my cell phone bill in half because I don't pay the provider to do text messages on the cell provider, and I also don't pay this company to do. I pay them like $2 a month for the phone number, and then I just get text messages, which is great, and voicemail, which is great. Okay. Anyway, enough about that. Code time. Okay. So when I wrote this, partly because the other guy in the project doesn't know Haskell at all, I decided to experiment with writing it in what's called Literate Haskell, which basically means that you do the opposite. Literate Haskell, or literate programming in general, is basically just the opposite of normal programming, where normally you write code, and then every now and then, if you're a crazy person, you insert some special marker that says, this next part is a comment, and then you write a comment. I mean, like, let's be honest, you don't write comments, you write code that is readable. But, like, maybe you wrote a comment once. So literate Haskell, you do the opposite of that. You just write words, and everything is a comment. And then sometimes you insert a little marker that says, like, this line is code. And the intent is to write bonkers amounts of words. Because, like, normally I hate comments because they're not really good at their job. But if you write really large amounts of words, then your code becomes less about the code and it becomes more about the story of what the code is doing, which is kind of neat. I've never done it before. I did it this time. And then I just pasted it into this thing and it looks like this, which is great for this purpose, which is basically the reason I'm presenting on this, because I was like, what can I turn into a presentation really fast? This thing. Okay, so we start here at the top and we're like, I'm going to make this thing. So I just talked here about how I'm just explicitly exporting my main function, and the reason I'm doing that is because it lets the compiler warn me if I don't use code. Because if I don't do this, then the compiler doesn't know because every symbol at the top of the file gets exported, then it kind of has to assume that all of those exports might be used externally, so it's not going to warn me about like useless code paths where I'm not actually doing anything. But if I just export main, then even if I have a top-level function that calls like 6 other functions and does all this stuff, they can look at that and be like, well, main never calls this, and nothing that main calls this, and you don't export it, so this whole piece of code is useless, which is great. So that's basically the only reason that's there. And then I switched to basic prelude because it's super fun. That's just a library. You can basically ignore that. And then I import all the things, which is like so not interesting, so I don't explain it in any words. Here we go. And then there's some constants, because why not? You need to have a name from a software and a version number. Everyone puts their version numbers inside their code, right? Obviously. So good. Okay. Yeah. And then like, see, so we have this nice story that starts here about how we have a data type to store our credentials, because I'm a bridge to Vitality. So probably I need to be able to store credentials for logging into Vitality. Seems like it makes sense. And it tells me what goes in here. It's just the DID and the password. Right here, DID and password. They're both text. I'm shocked that these would be text. And that's where our program starts. Here in main, the only thing that we export. And we do some fun stuff. Like we set up our we set line buffering on stage. And you're emitting like, ha! How are you? Can you see this? You can't see this. It's still in the big 4K buffer. So I do this now, and now my stuff actually shows up in log files. Because, like, why would I write code that knows how to open a file and write log messages to it when I can print a standard out and redirect to a file? But then I still have to do this. Yeah, that's what I do. Then I get some command line arguments. Always need some good command line arguments because I obviously don't want to write a thing that parses a config file. That's bonkers. Just give me stuff on the command line. Everything on the command line all the time. It's the fun way to write programs. Everything is on the command line and on standard out. And that's the whole. Then I don't need, except for this. I have a database, so you know, sad times. But I just hard code the name of the database. Obviously, why would I pass on the command line arguments the name of the file to use for the database? It's just going to be called DB. What else do you call a database? I'm not right. So I make some queues because basically every time I start to write a program these days, what ends up happening is I write lots of threads all the time, and they always talk to each other with synchronized queues, because that's just the way I think about programs now, especially in Haskell. It's very hard. I'll start writing a program and I'll be like, I don't think I need threads in this program, and about an hour later I'm like, oh, look at these 4 threads that I have. It's so good. It's really fun. I like threads. They're very nice. They do their job well. Okay. Actually, I was thinking about this thing yesterday that I was trying to build, where I thought, oh, you know what? This is the perfect place to use coroutines. I have like a bot, basically, I have like call response bot, and I was like, this is exactly what coroutines are for. I can like save the frozen coroutine halfway through and go back and forth, and then eventually I realized, look, I'll just use a thread. It's better, because then I don't have to use an extra library for coroutines. I can just use more threads. Threads are free. And threads are not usually free, but I'm in Haskell, so threads are free. Okay. So I make some queues, and then I open my database, and then I'm probably not starting the program for the first time. I mean, you're reading this as a narrative, so it's a little bit confusing at this point. This is what happens when you read your narrative later after you wrote it. See, comments are off. Don't write comments. This is a bad idea. So, but like, probably you're not running the program for the first time. On average, the program is probably being run on for the first time in all cases except for the first time. So like, seems good. So we should maybe look in the database and see if we ever put anything in there before. Basically, if you think about it, I'm a gateway between XMPP and Vitality. So what's in my database? Probably a lot of usernames and passwords for Vitality to log in. So maybe I should log them all in. But I don't actually want to log them all in because it's obviously I'm going to have to be able to log in like while I'm running. When people add new ones while I'm running, I'm not going to restart the whole program every time we add a new one. So I don't actually want to log in. What I'm going to do is I'm going to read out all the keys. I'm going to loop over all the keys right here, and then and then I get them because the way Tokyo Cabinet works, I get a list of keys, and then I loop over the keys and I like fetch the value at each key. Because it won't give me the keys and values all at once. Whatever. Yeah, Tokyo Cabinet. Yeah, and then I just like read that so that I can have it parsed out as my nice credential data type that I defined earlier. Do the things. And then I just shove into this queue that I got a new registration. As though someone just for the first time sent a registration while I was running. Instead, I just queue up a bunch of registrations before I've even done anything. It's the first thing the program does. It boots up, looks at the database for all the old registrations, and shoves them in the queue as new commands, as though they just happened for the first time. Because then later, the manager can read off the queue and handle everything, which is great. Yeah, it's almost done this part. This is the part where I actually connect to the XMPP server, which is good, because I'm going to need to do that. And I run forever, and I just print exceptions. So basically, I'm like, connect to the XMPP server, and if anything goes wrong, print that, and then do it again. Forever. Because I don't want to stop running, and if anything went wrong, probably it was just like the connection died, or you restarted the server, or something. I don't know what happened. Probably it's not a big deal. Just keep going. This does mean that if something in my code is a bug that actually causes an exception every time, that it just runs forever printing the exception out. But probably I will notice that, so it's fine. Okay, all good. This is the best way to handle exceptions, you guys. You just log them and then keep going. What else could you do? Okay, and then finally we start up the thing that connects to Vitality. All good. So, in here, I have, after it connects to the server, it hands control over to this thing. This is where it takes where we handle all the talking to the server. This chunk of code here handles all of our outbound. So I've just got this queue, because obviously we need lots of queues all the time. That's the program I wrote. So all this queue does, all this whole code does, we fork a new thread, and then we just read stanzas off the queue, read XML messages for the XMPP protocol off the queue, and then we send them to the server. That's all this code does. So basically all it's doing is owning that connection to the server to make sure that multiple threads aren't all trying to write to the same network socket all at the same time and putting their bytes in between each other and making things bad, because that would be bad. I mean, let's be honest, I run this program single-threaded. But like, if I did run it multi-threaded, then, you know, they could be at the same time and that would be bad. So we do this, to like, for synchronization or whatever, it's fun. And then, you know, same thing, run forever, and if there's any errors, print them, because that's how we handle our errors in this program pretty much. But then we want to get the thread ID, because we're going to handle errors in a different way in a second. It's very fancy. So check this out. Down here, we're going to, this is the other side of this thing, we're going to pull all the incoming messages off of the network socket, so there's only one place that handles that, and then we're going to like pass them into another function that actually handles them. But if we have any errors in here, then we print them out, and we kill this thread. And then we die, because there's no forever here. Well, there's the forever inside. The forever's inside the cache. So we're like looping forever, getting these things off, but if there's an error, then that'll go outside, get caught, but then all we do with the cache is log and kill this thread. So what this does is it makes it so that if the connection to the server gets completely hosed, or if we have some kind of super bad error here, that both of the threads that are handling both sides of the server connection die, because we kill the other one, and then we stop. And that will cause this whole thing to return, which takes us back up here, where it says forever, and then it reconnects. That's all that does. And it won't log anything. Well, actually it will, because this log is actually super fun. It's like, it catches all exceptions, and then it prints out the result of either the exception, or if there was no exception, it just prints out like, success, anyway, try again. Which is great. So good. You can tell I put a lot of thought into making sure my logs are very clean and happy. Oh yeah, all the time. Okay, so what we do if we get a message inbound is we just send it to this other function and we say, here we go, figure out what to do with this anyway, and then the function is expected to return a list of things to send back. So we just take that and we shove them all into the queue that the other thread reads off of so that that's all synchronized up nicely. That's what we do. And this is basically just a giant pattern match, this inbound statement thing. It just goes and says, okay, what kind of message have we got? Maybe it's a message, because there's more than one kind of packet. But the message packet is probably the most interesting. You're sending a message. So we're like, okay, if we get a message, then we'll try to map the thing you're sending a message to a telephone number, or to a identifier back over at Fidelity, because that's what we're a gateway to. Can't lose sight of our goal here. So if the mapping succeeds, then we will get this mapped identifier, and we can do the stuff. So it succeeded, so then we try and get the credentials out of the database, because if we don't have any credentials, then probably we don't know, you're not registered. And then if this is an error or of some kind, like if the message you're sending me is an error message, then I do nothing. The reason I do this is because if I send an error to you, and then you send an error to me, and if you send an error to me and I don't know who you are, then I send an error to you. But then if you send an error back to me for some reason, now I still don't know who you are, so I send an error to you, and now we're sending errors back and forth forever. So I just kill the loop right here. I'm like, if you send me an error, I just ignore you, because I don't know who you are. I'm not going to error about your error when I don't even know who you are. Just stop. That's what that's about. Otherwise, I don't know who you are. So return this error message. Don't know who you are. Yeah. Otherwise, if I do know who you are and you send me an error, then I can do some fun stuff. Basically, where I send an SMS message that says error. Right? Because remember, we're on the other side of the gateway. So assumably, if I get an error, it's because someone tried to send an SMS, I tried to relay it, now I've got an error back. So I send that guy back an SMS being like, sorry, couldn't send your message, here's what I got told. Couldn't do it. Right? But I can't do that if I don't know who you are, so instead of returning an error, I just return nothing, because otherwise it'll bounce forever. Because I already got an error before. So if I send you another thing, probably I'll get an error again, and that's bad. It's actually super, super fun looking at my logs, because in XMPP in general, what happens when you send an error back is you keep the whole message, the whole packet the same, and you just add to the end a little line about the error, but you reflect the whole packet back for debugging reasons, basically. So when you get an infinite error loop, you just get this infinitely growing packet as each side is appending its error message to the other side's error message. It's super fun. Yeah. It's super great. Yeah, so that's why I don't let them do that anymore. That's good. Good stuff. Otherwise, it's not an error, and this other side means nothing. That's the body, because up here, I'm so good at explaining things, you guys. It's the best. Where did I start this?
Right there. Get body. Next block up.
I can't see things. Yeah, here. What I'm matching on is the credentials or the body, like the attempt to extract a body. So this is like no credentials, this is credentials. So then down here, like we have credentials, but we don't have a body. Well, I'm not going to send a blank SMS message. I mean, I could. I don't even know if I could. Like, how would you, what would that, I don't know if that's even allowed. I have no idea what would happen if I tried to do that. So I'm not going to send a blank SMS message. I could turn it into an SMS message that has like just a single space in it or something to make it deliver, but why? Why? Just don't do that. So I send you back an error being like, fuck off, you have no body. Get a body, come back. But if I have credentials and a body, then I can send an SMS message with the body. Right? And how do I send it? Obviously by saying send a fidelity command, which is just basically stuffing in a queue, obviously. Because everything, this whole app is threads talking to each other about queues. The most important architecture in the world. So good. What happens if my app crashes while stuff is in the queue? It doesn't get sent, obviously. It's your problem. Stop crashing your apps. Make them run forever. I don't know. That's a different problem for a different time. don't turn things off, and everything will be good. So yeah, so I build the message that says to send an SMS, and I stuff it into someone else can handle that, and then I return nothing. I don't send anything back. Because you sent me a message, I'm going to relay it. I have nothing to say to you. Like, okay, there, did that. If I had some way of knowing whether it got delivered or not, maybe I could say back to you like, got delivered, yay, but I don't know that. Fidelity doesn't tell me. Like, probably it got delivered. I don't know. So, there you go. Otherwise, see, this is so good. So remember up at the top where I said, I'm trying to map this to a telephone number, and if it is, I do all this shit? Otherwise, it's not a valid telephone number, so fuck off. It's bad, not a telephone number. Invalid. Right? And basically the whole rest of this kind of goes in the same way. It's just these nice patterns that say like, what kind of packet am I getting? Well, this is one where it's asking me if I'm online or not. I'm on SMS. I don't have online, offline, away, busy. This is not a thing I have. I'm just an SMS. So like, I guess I'm online. Why not? So I just say, yeah, I'm online, available. And then I also tell you this fun magic string, which basically tells you what capabilities my client supports. Because I have a client, obviously, it's myself. So I'll just tell you what I support. And it's just a hash, basically, of well, I'll show you. Down here, it's another online thing. Otherwise error, because like, we don't know who you are. This one says if you try and subscribe to my presence, I'd just be like, okay, I guess so. Yeah. But here, no, this is registration. Okay, that's fine. So yeah, it's the same kind of thing. So if people need to be able to give me their username and password in the first place, so if they say to me, hey, I want to get, see look, get, right there. It's hard to read the black lines on it. There, get. I want to get from you the registration, right? Then I'm like, cool, here it is. Please enter your DID and password. Give me your phone and your password. That's what I say to you. And then probably you say back to me something that contains phone and password but with values in it. So I take the values, I get them out, boop, and I try and normalize the phone number because maybe you typed all kinds of weird garbage in there for your phone number. I want to make it not garbage. You put the plus in front and the 1 and stuff. It's very easy to normalize because Fidelity only supports North America mostly. So I can mostly be like, does it start with a 1? If not, you're wrong. I'll just put a 1 there for you. And I'll check if it's 11 digits long. Is it 11 digits long? Hooray! Probably it's fine. But then after I do all that, then I do this fun thing where I try to connect to Fidelity with the credentials you just gave me. Because I want to check if your password is right. I'm not going to just store these in my database. Maybe they're bogus. Why would I store in my database a bunch of bogus passwords? Then I get into these infinite loops where I'm trying to reconnect forever. That's not good. So I just try it. This is super fun. So it's just a connection thing. It's the same kind of connection runner that I showed you earlier when we were setting up this whole component in the first place. But instead of looping forever on error and printing stuff out, I just say on success, true, on error, false. And I assume that all errors are authentication errors. Because what other kind of errors could there be? Nothing, right? So if no success, then I say off error. Give me a better password. Your password is wrong. Otherwise, put it in the database because we know it's right. And and send that registration. So this is the same command we saw earlier when I read from the database. I send this like 1,000 times. Here I just sent it once because you just, while I was on, gave me a new password, so I send it over there. Somebody will connect for me. All good. And then I reply saying like, all good, hooray. Otherwise, like, nope, I have no idea what you just sent me. You sent me some kind of random garbage. You didn't even put a phone number in here. Something is broken. Alright, so it kind of goes along this way. And so this is the thing where I talked about all the capabilities my client has. So like I have the ability to be registered with. You can ask me what my version is. You can ask me for a V card, which exists mostly so that I can tell you about myself. Yeah. So and that's what this thing is the thing that I have the hash of above that we saw before. Yeah. So those are there. And then this is the V card. Look, it's so good. It tells you what my home page is for my software. And then it tells you like what the software is. So if you just found this software out on the webs and you were like, hey, well not the webs, the XMPPs, and you're like, hey, I found this cool gateway, what is it? You could just ask it for its right-click information and it would be like, hi, I'm this guy. you can get the source code from this place. Go here. It's so good. And then you go to the source code, and it's this little blog post formatting thing, so you can read it or not. Probably not. You'll probably be like, what is this? Stop. My eyes. Oh no. Yeah, if someone asks us for our software version, that we tell them, this is my name, this is my version. That's why I had those up at the top. It's so good, so people can ask me. This works too. You go into your chat client and you hover any of the SMS things, and they're like, yeah, it's from this gateway guy, which is totally useless, but it's fun. And it took like 6 lines of code, so why not put it in, I guess. If you ask me for anything else, I say, I don't know how to do that, which is pretty good. And if you send me anything at all that I didn't match above, which like mostly shouldn't happen, then I just log out to myself, wow, what is this? What, maybe make this the thing you know about. Yeah. That's most of the, that's like a lot of the good stuff. Like this is all like really simple stuff, so here, this is my mapping to find out if it's a phone number, right? To find out if it's a phone number, I say, does it start with +1? If it does, it's a phone number, woo! Just add this SMS to the end so we can send it over to Vitality and we're all good. If it doesn't start with +1, then fuck off. I mean, also, it has to be all digits, only numbers in it. If there's like an R in there, then that's probably not a phone number. It's not true. And we're going back, we do the same thing, only going back we support international numbers a little bit, a tiny bit. So we say, if it's 10 digits long, because Vitality only uses 10-digit numbers because they assume you're in North America. So if it's 10 digits long, then add +1, because then now we're all good. Otherwise, it starts with 011, so that's their international. Phone numbers are weird, you guys. Phone numbers make no sense. Every place, you're like, here's my phone number. That's not your phone number. That's just a string of digits that if you dial it from some phones, it might get you. Other phones, you dial random other digits. Phone numbers are bonkers. Anyways, so the 011 thing, that's apparently one of 3 valid North American international dialing codes. There's 011, 00, and something else. And they all work, sort of. It depends on what you're doing. Anyway, they use this one for text messages. I don't know. So I take it off, and then I add the plus, because the country code is there. Because it's not like dial country code and then dial phone number. That would make too much sense. You dial 011 always, and then a country code, and then a phone number? Phone numbers are weird, guys. I don't get it. Okay, so that's fun. We got our normalized phone number. We're like, hey, is it 10 digits long? Then add +1. Is it 11 digits long? Is the first one a 1? Then add a plus. Otherwise, I don't know what it is. Stop it. You're hurting me. That's it. That's what it does. So good. Should probably do something better than that, but like, that works sometimes. Lets people at least type. I do also do other things. Here it is. I also get rid of all the things that aren't numbers. So you can type with all your separators, and then I just take them out again. And then I check, is there 10 of these? Great. Now, that's how that works. We got the 2 commands that we've already seen being sent. That can be sent to the Vitality management server thing. Send an SMS, and new guy sent me a password. And the internal state, which basically maps a set of credentials to this bonkers looking thing, which is queues. It's 2 queues, obviously. It's actually a thread, but I'm not storing the thread. The thread just exists somewhere. I'm storing the queues to use to talk to the thread. But I'm not storing the queues because queues you can put things into and take things out of. You only need to be able to put things in. So I'm just storing the actions you use to put things into the queues. That way you can't take things out of them, which would be bad. If you took things out, then I wouldn't have them, then where would we be? Very sad. That would be bad. So this thing is just like, it's very similar to what we saw before. I found a hack to it. I should rewrite this with my new hack. Anyway, this is just a thing that's an infinite loop that's like, okay, get stuff off the queue, and then process the stuff off the queue, and then loop again. Why do I write the loop like this instead of using forever like before? Well, because what happens is I have this empty map, this kind of map up here. I pass in the empty map, and then whatever you pass back is my new map. And I'll pass it to the next guy. State! Who needs state when you can build it yourself with an infinite loop in a thread? This is part of the reason I have so many threads, you guys. Every time I'm like, man, I could have a stateful variable. I'm like, or I could have another thread with another infinite loop. It's really fun. I may have written too many operating systems. It makes me think this way. Anyway, here we go. So this one's way simpler because there's very little that you can do here, right? Either you're sending an SMS message, so then I'm like, cool, this is an SMS message, so we just look up in our sessions map, that map that we've got, to find the connection. Because like every single person who's sending a message is going to have to go up a different connection to Fidelity because they're all authenticated with a different password, right? So we just pull out of this map the connection that we want, and we shove the SMS in there, and then they will deliver it for us. Hooray! Or we didn't find a thing, so it would like error, because I don't know what to do. Oh no, actually, if we didn't find one, that's not what we do. If we didn't find the session, we already have the username and password. You gave it to us, so we try and make it connect. Hooray! Because that's what you need to do if somebody like sends a registration while I'm already running. I need to be able to. But this is also how we connect in the first place, because we just have the big list of stuff, so we connect them all up. It's okay. Yeah. And then over here, if we get a registration, then we just like add the subscription, do the things. If we get a registration and we're already connected, then we just say, this is another guy you should notify. So that if multiple people register with the same password, I don't connect 6 times, I just connect once. And every time I get a message from it, I send it to all those guys. Because they all have the same password. So it's all the same guy. And if we're not already connected, then we connect, do the thing. This is the part that connects. Which is like super less interesting. You can tell because it's like more code and less text here. But it's just like, yeah, okay, like send the thing. Basically. Come on, scroll down. We don't care about this part. Oh yeah, when we start up, we should say we're online. That's fun. Because if we don't say we're online, the Fidelity just won't talk to us. It's not really relevant that we say we're online, because no one's listening except them. And they already know we're online because we opened the TCP socket to them and gave them our password. And they said, yes, that is a good password. But they won't let us do anything until we then say, I'm online. And they're like, I know, but anyway, now that you've said it, now you can talk to me. Whatever. Good times. Oh, and then this is a fun part. Every time I send a message to Fidelity, then I wait for a random amount of time. Because they're kind of shitty. And if I do this, it's more likely that my messages will be delivered. I think it's part of their like anti-abuse policy, because officially their policy says you're not allowed to automate it at all. This is not automation, by the way. This is just code that enables human-to-human communication. Therefore, not automation. So I'm totally fine. This is not a terms of service violation, in my opinion. Right, they're worried about, but basically what they're worried about is they give me unlimited text messaging for free, and they're worried about me being like, woo! So if I like wait a random amount of time between messages, it makes it look more like a human is sending them. Because it turns out humans can send messages really fast, especially if they're using computers where they have access to clipboards, and they can be like, paste, 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 and then Fidelity's like, this does not look like a person-to-person conversation to me, I gotta stop that right now. So we just put random weights in there, it's all fine now. Usually it's fine.
Even when you've got error messages upon error messages upon error messages.
Right, the infinite error messages, yeah, that gets really, yeah, they don't like that. This is another one of my fun live forever and print errors things. I got so many of these, you guys. Usually it's fine. Yeah, that's where if I get an error message in, then I just send it back. So this is a fun little proxy thing I do right here, where I make the ID of the messages I send to Fidelity be the ID of the message I got from the other side, plus the address of the person who sent me the message. And I make that the ID of the message I send to Fidelity. And then if they send me back an error, errors have the same ID as the message that you sent in the first place. And then I parse the ID on the error to get back the original ID and the person I should send the error back to. And then I send that guy the error with the ID set to the ID he originally had so that he gets an error whose ID matches the message he originally sent me. And then his client will get the error, so the errors just pass through magically. So that's what I'm doing right here. I'm just reading, I'm doing the parse to try, on the ID to try and figure out what the ID and from should be to send this error back to. Which took me a while to figure out what I should do. But a lot of times I end up doing this with XMPP. It's like I could build this whole extra piece of state to remember the ID I gave to the message and then map it back to the guy who sent it and stuff. Or I can just take the name of the guy who sent it, stick it in the ID, and then you'll give it back to me yourself. I don't have to remember anything. So good. My other app that I'm not going to show you has way more of that. I put like weird, fun prefixes on the IDs all the time, and then when I get a message with that prefix on the ID, I'm like, that's because I made this message, and I am getting it back for some reason. That's always what I do. Way easier than trying to do something real, like having steak. Screw that. Oh, this is an extra fun part. Sometimes Fidelity sends you messages that are not text messages. They're just random messages they decide to send you for no reason. For example, sometimes they send you the message, you are not authorized to send SMS messages. Maybe they do that because they think I'm a bot. I don't know why they send that to me. Anyway, you don't want to see that. You're the user who's sending text messages from your phone. You don't want to see a message that says you are not authorized to send SMS messages. So what do I do if they send that to me? Nothing, I ignore it. That's what I do. Very good. Also, sometimes they have messages that start SMS server. So this is super fun. I don't know. Again, this is just the bonkers way sometimes people want to build things. So when you message someone for the first time with Fidelity, instead of just delivering your message, because that's what you asked them to do, they deliver your message, then they add that person to your contact list, even though you didn't ask them to do that. You just asked them to deliver a message, but they add them to your contact list anyway. Then they send you a message that says SMS server in parentheses, and then says like, I just added this guy to your contact list because you talked to him for the first time. Hooray! It's like, why are you sending me? I want to send a message. I don't want to get a message from you. So I just, if I see that, I'm like, nope. No, they don't see that anymore. This is what I mean. I'm like papering over all these weird things. I got this random delay. I'm ignoring these messages. A bunch of stuff like this where like I just make it a better experience. And that's it. See, I said that's it right here. There's like all this code left down here. But that's it. Like, nothing else down here is because everything else down here is really, like you thought it was boring before. This is really boring. Look, this, all this does is connect to the server. Like, it's just like some boilerplate. I have hard-coded the name of the server because I know the name of the server because it's a breach to Fidelity. They only have one server, just the name of it. There you go. That's the port that server is on. Right, like all this super boring shit is in here. And also I have some stuff in here where like I catch every exception and do some handling of it, which means that up here I get to say that my result is unexceptional. No, I have an unexceptional result. No exceptions in there. Super fun. What else I got in here? Super fun things. Fetch credentials, which just like goes to the database, looks at a thing at this key, and then parses it. That's what it does. Make SMS is like, I want a new message. It's a chat message. It goes to somebody, and it has only one payload, which is a body with this text in it. Right? This is actually very important. If you send Fidelity a message packet, and the first element in that packet is not a body, they just ignore you. Even if you have a body in there, and you have other things also, like say you have a subject and a body, it's not just that they don't send the subject, they just don't do anything. And they don't send you an error either, they just do nothing. If you send body then subject, they'll send the body, ignore the subject. But if you say subject then body, they just ignore you. It's super fun. I have patched a number of chat clients, because I've been using them directly, I've patched a number of chat clients where I reorder the stanzas so that body always comes first. And the guy, when I send my pull request, is always like, why do you need this to come first? It doesn't matter. It's XML. It doesn't matter what order things are in. I'm like, it does for these people, and it doesn't matter for anyone else, so we should just do it. And they're always like, this is really stupid, but okay. And then they merge me, which is super fun. But now they don't have to, because I can send whatever I want to this gateway, and it'll